before I forget. All right, so during our last lesson, right, we started talking about the mean of absolute deviations. Okay, we started talking about the mean of absolute deviations, and we did the 2.4a, right? We did our 2.4a activity where we looked at the variability in some basketball statistics. And we ended our class with the following journal entry. Okay, we ended our class with the following journal entry where we kind of summarized, right, our own understanding of the mean of absolute deviations. Okay, we kind of summarized our own understanding of the mean of absolute deviations here. So if you remember, right, mean of absolute deviation, okay, this was us finding the average, right, of the absolute deviations. And where the words absolute came from was we took the absolute values, right, of the deviations, of the differences. Okay, so we found the average of the absolute values of the differences. Okay, and so with this, we had our whole 2.4 had a whole nice table for us. And we worked through that table together. We worked through that table together here. And give me 1 second. Thank you. And as we were working through that table, right, we were finding our mean of absolute deviation. So we're going to be doing a similar thing today. We're going to be working through a table, but instead we're going to kind of be drawing our table ourselves. And then you guys are going to do an activity yourselves as well where you practice it. Okay. So looking at our first set of notes for today. So the process for finding the mean of absolute deviation, this value here, this process is actually a formula. Okay, we were actually completing this formula here. So the mean of absolute deviation measures the absolute distance of each data point from the mean, and then finds the average of those distances. Okay, so when we say we find the average, right, finding the average of something or the mean is just adding everything up together and then dividing it by the number of items or observations that we added together. Okay, this symbol right here, this symbol might be familiar to some of you, and it might not be familiar to some of you. This symbol, okay, this is called, it's a Greek letter. It's the uppercase for the Greek letter sigma. Okay, it's uppercase for the Greek letter sigma. But what it means in mathematics, what it means when we see this symbol, it means sum. It means add all together, right? Okay. So Janelle, yeah, you were kind of right on the thing. You said, you know, all of the numbers. Yes. Okay. So we're adding all of the numbers together. So when we see this right here, it's telling us to add all of these numbers together. But what are these numbers? Okay. What does X mean and what does X bar mean? Okay, well, the X is the actual individual score. So these are our actual observations, our data points. Okay, the data, each individual observation. Okay, X bar. Okay, notice it's an X with a bar on top of it. We literally call this X bar. This is the same thing as our mean. This is the same thing as the mean, finding the mean. So this is our X bar. Okay. And then N is the quantity of the score, so the number of observations. The number of observations, that's n. Okay. So I'm gonna give you guys a minute to get all of this down, okay? And then I'm gonna show you how we were actually doing this using our table on 2.4a, okay? So in reality, most of the work for finding the MAD is figuring out the numerator, figuring out each data point minus our mean, and then absolute valuing that, and then finding every single one of those, and then adding them all together. So plus and so on, right? So that's why the table helps us. Yes, that says table. That says table, okay? So I'm gonna give you guys another 30 seconds to get all of this down. Okay, anyone need more time with this? Anyone still writing? Okay, thank you for the communication. You guys are awesome. So I want us to take a look. So remember this formula, right? MAD is equal to the summation, the sum of each of these values, right? X minus X bar, so data minus mean divided by N. Okay, keep that in mind, because when we take a look at our 2.4a, okay, take a look at 2.4a, right? This is the table that we use to find Chris's score on 2.4a. So the scores that we were seeing here, these were the X's. These were our X's, okay? The mean that we found, that's our X bar. So when we were doing the mean minus the score, when we were doing this right here, we were doing X bar minus X, okay? Which, because we end up taking the absolute value, it's the same thing as doing X minus X bar. So we could have easily done score minus mean here. Okay. So what ends up happening is when so essentially, right, remember the formula, we have this sum of X minus X bar, right? Absolute value of X minus X bar divided by N. Remember that formula, right? That's our MAD formula. Okay, so here's the X minus X bar part. That was this table right here. Okay, this right here was just whatever this resulted to, right? So this was still X minus X bar. It was just the final result of it. And then what did we do in this column? We took the absolute value of whatever we got here. So we were literally taking the absolute value of whatever X minus X bar was. Does that look familiar? Okay. Then, right, this is each individual data point. So this is a data point, this is one, 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 so on and so forth. But the top here, the numerator, is the sum of all of these. And where did we find the sum of all of those? Right down here. So when we added all of these up, we were finding the sum of X, sum of absolute value of X minus X bar. That was this guy right here. Okay. Then, what did we do? We took this sum, right? We took that sum and we brought it right over here. Okay, I'm going to erase a lot of this. We took that sum and we brought it right over here. And we put it right at the top here. That was our sum right here. Absolute value of, I'm sorry, summation of absolute value of x minus x bars. And we divided it by 8. Why 8? Because we had 8 data points, right? We had 8 data points, aka our n. Okay, so we literally were doing the formula, but again, we were doing this top because if you're going to do this by hand, and when you do this by hand, you have to keep it organized. If you don't keep it organized, it is so easy to get lost. It is so easy to get lost if you don't organize it. Okay, so majority of the work for finding the mean absolute deviation, the MAD, is figuring out your numerator. Once you have your numerator, then you just divide by n. So that entire table we were doing was to find our numerator. Okay, so I want to show you guys an example. So I'm going to go back to our PowerPoint here. I'm going to go back here. Okay, and we're going to take a look at this example here. It says calculating the MAD for personality color data. So we're going to compute the MAD value for the blue scores. So this isn't our blue scores, it's just some blue scores, right? Some random blue scores. Okay, so we're going to calculate the MAD value for these blue scores. Okay, and we're going to answer this question of, does the MAD value seem reasonable based on the dot plot? Okay, so looking at this dot plot, do you think there is a good level of variation, or do you think that it's not, like there isn't much of a variation? What do you guys think? Let me know in the chat. What do you guys think? Do you think there's a nice variation, or do you think that there's very little variation? Okay, thank you, David, for coming through with that chat. Thank you, Janelle. Yes. Thank you, Vicky. Thank you, Val. Thank you, Sarai. Thank you, Maddie. Thank you, Evelyn. Thank you, Natalie. Very nice. I like it. Very good. Yes, yes. Okay, so majority of you are saying that there's a good level of variation, right? There's a nice variety in our data here. So what does that mean about our MAD? Let's make an assumption. Do you think that MAD is going to be closer to 0 or farther from 0? What kind of an MAD means there's good variation? The one that's closer to 0 or farther from 0? Right? Let's take a look back at just reminding ourselves here from our essential concepts for the day, right? Over here, it says the larger the value, the greater the variability. The larger the value, the greater the variability. So does that mean that our MAD is going to be a larger value or a lower value? AKA, will it be farther from 0 or closer to 0, right? All right, good. I'm getting farther, I'm getting larger. Okay, so we should expect a larger MAD, right? Something not that close to 0. Okay, so how are we going to do this? How are we going to make sure we get our MAD? Well, the first thing to do is to figure out what each of these dots mean as far as our data points, right? So we got to figure out what our x's are. Okay, we got to figure out what our x's are. So we use our dot plot. We have 1 dot above 5, so that's going to be a 5. 1 dot above 7 here. We don't have anything for 6, so 7. We have 1, 2, 3, 4 dots above 8. So that means I have 4 8s. 8, 8, 8, and 8. Right? So 8, 8, 8, and 8. I have 1 9. I have 1, 2, 3 10s. So 10, 10, and 10. Okay. I have 111, 1, 2, 3, 4 12s. So 12, 12, okay, 12 and 12, okay, 113, 1, 2, 3, 4, 5 14s. So 14, 14, 14, 14, and 14, okay, 115, 116, I don't have a 17, so 118 and 119, okay? So now that I have my data points written, I'm gonna move over to this slide so I have more space to work, okay? So you see how long my numbers are here? You can't work on a table, right? So what we wanna do is we wanna create a table just like the one we were working with, right? Just like the one we were working with. So we want to create a table and we want to be able to do the x minus x bar, right? So x minus the mean. And then we want to be able to take the absolute value of that, right? So this is our x minus mean column. So then this is going to be our deviation, right? So whatever this results into, so that we can easily see what that is. Okay. And then then we're going to take the absolute value of whatever that was. So the absolute value of x minus x bar, right? So that's going to go right there. And then we'll figure out what the summation of all of this is. And then we'll finish out the MAD. So, but the first things first is I got to list all of my x's here, okay? So here's the issue that I have. I don't have space to write them all out. This is guys a good example to have in your notes. For sure, this is a good example to have in your notes. Okay. So here's the problem that I have, right? I have way too many data points to fit in my space here. So I'm going to do something. I'm going to show you guys a trick. Okay, I'm going to show you a trick, so pay attention. Okay. I'm going to take the ones that repeat and only write them once. Okay. So I have 5, I have 7. Hold on, that's using up too much space. I have 5, I have 7. And then I have these 8s. I have 4 8s. Okay. So instead of writing 8 4 times, I'm going to write it once, but I'm going to write myself a note here that 8 shows up 4 times. Okay. I don't multiply them. No. I don't multiply them because I still got to work with that 8. Okay. Not yet. I just keep track of the fact that I have 4 8s showing up. So I have an 8, an 8, an 8, and an 8. Okay. Then I have a 9. Oop, wrong color. Then I have a 9, right? And then I have 1, 2, 3 10s. So I'm going to do the same thing. Instead of writing 10 3 times, I'm only going to write it once. Okay. I'm definitely using way too much space here, guys. I got to condense a little bit more because I'm going to run out of space very soon. Okay. All right. Then I have an 11. I have a 12, but I have 1, 2, 3, 4 12s. So I'm going to do the same thing. I'm going to keep track of the fact that I have 4 12s. And you're going to see how this comes into play at the end. Okay. So I'm showing you a shortcut. I'm showing you guys a shortcut. Okay. And then I have 13. I have 113. I have 1, 2, 3, 4, 5 14s. So I'm going to write my 14, right? I have 5 14s here. And this is going to be 5 times 14 right there. Okay. And then I have a 15, wrong color. Dang it. Sorry. I have a 15, I have a 16, I have an 18, and a 19. Okay. Now, I want to be very clear. Okay. If I had had the space to write out all of my numbers, what this means is I would be doing the 8 minus x bar, right, 4 times. I would be doing 10 minus the mean 3 times. I would be doing 12 minus the mean 4 times because I have 4 12s. I would be doing 14 minus the mean 5 times because I have 5 14s. This way, I only have to do it once, but then I keep track of how many times it should be there. Okay. So I need my mean now. I need my my average. So the first thing I got to do is I got to actually find my mean. Okay. So I'm going to do that. And we find our mean by adding up all of our numbers together, right? And dividing by how many data values that we have. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So my n is equal to 25. I have 25 data values. Okay. So then to find my mean, stop it. To find my mean, I add all of these guys up together. Okay. Add all of them up together. So I have 5 plus 7 plus, I have 4 8s. So I can do 8 plus 8 plus 8 plus 8, or I can do just 4 times 8, right? Plus 9 plus 10, but I have 3 10s. So I can do 3 times 10, right? Plus 11, plus I have 4 12, so I can do 4 times 12, plus 13, plus 1 5 14, so 5 times 14, right? That's the same thing as doing 14 plus 14 plus 14 plus 14 plus 14. Okay, plus 15 plus 16 plus 18 and plus 19, all divided by 25. Okay, all divided by 25. So when I add all of those numbers up together, okay, I get 293. So for x bar, we get 293, yes, divided by 25, which gives us 11.72. That gives us 11.72. Okay. So what does that mean? That means this right up here, okay, that's my x bar. So this right up here is going to be x minus 11.72, right? My x bar is 11.72. Okay. So I take my mean, and I'm going to use it now to find the distance, right? The difference between each data point and my mean. So each one of these, this is going to be x minus, not x, I'm sorry. This is going to be 5 minus 11.72, 7 minus 11.72, 8 minus 11.72. So over here, if I had listed all 4 8s, I would have 8 minus 11.72, 8 minus 11.72, 8 minus 11.72. Okay. So I'm cutting my work by looking at the fact that there's duplicates. And we're going to keep track of this. Over here, 9 minus 11.72, 10 minus 11.72, and so on. We do this for every single data value, right? This is just like our table, guys. Just like the table that we had on 2.4a. okay? So then we actually find our deviations, okay? We actually find our deviations here. So 5 minus 11.72 is a negative 6.72. Okay, this is going to be a negative 4.72, negative 3.72, negative 2.72, negative 1.72 is going to be negative 0.72. Now 12 minus 11.72 is going to be 0.28, 1.28, 2.28, 3.28, 4.28, 6.28, and 7.28. Okay. I know that was really fast, but you kind of just use, like, if 12 minus 11.72 is 0.28, then 13 minus 11.72, that's one more, so it's 1.28. I just use that sense there, that math sense. Okay. Then we take the absolute value, right? So we want to take the absolute value of each of these so that whatever's negative turns to positive. So these negative guys up here now turn into positives. And whatever is positive stays positive. Oop. That one looks bad. Okay. So this is where now we need to be careful. Okay. Anyone need me to stop for a second so you can catch up with the notes? Because this next part is very important that you understand it. Because we're bringing these guys back. We're bringing back the duplicates now. Okay. Okay. I'm gonna Val, about 30 seconds, huh? Okay, go ahead. Okay, just finish up writing, guys, and finishing your table here. Right. So what we did is we took our data points, we subtracted each one from the mean, right? I'm just doing a recap. Subtracted each one from our mean, and then we took the absolute value of those differences. Okay. So now we want to add, we want to find the sum, but we don't just add these guys. Because of these duplicates and the way that we did them, right? Because of the fact that I only wrote this one, I only wrote 8 once, but I should have written it 4 times. I only wrote 10 once, but I should have written it 3 times. I only wrote 12 once, but I should have written it 4 times. I only wrote 14 once, but I should have written it 5 times, right? Because of this, I need to do something now here before I add anything. Okay. All right. Valhan, you ready? Okay. So there's a few ways to think about this, right? So if I should have written 8 4 times, that means this number, instead of showing up once, it should be on this list 4 times, right? It should be on this list 4 times instead of just showing up once, because I should have 4 lines of 8. I should have 3 lines of 10. I should have 4 lines of 12. I should have 5 lines of 14, right? So these numbers should be showing up as many times as I had those numbers, right? So you can list it out like this, or we can do what we did when we were finding the mean, which is we can multiply it by how many times that it should be showing up. So we could do 3.72 times 4. We could do 1.72 times 3, 0.28 times 4. Oh, that looks really bad. Okay, and we can do 2.28 for the 14 times 5. So what this now gives us is I get 3.72 times 4 is going to give me 14.88. So that's the same thing as having 3.72 plus 3.72 plus 3.72 plus 3.72. Okay. And then if I do 1.72 times 3, I get 5.16. So 1.72 plus 1.72 plus 1.72. 0.28 times 4 is 1.12. So that's the same thing as adding this 4 times. So instead of adding these numbers, I'm now going to be adding these numbers to account for how many times it should have shown up. Okay, 2.28 times 5, same thing, is going to be 11.4. So I am making sure that all 5 of these are accounted for by making sure that I multiply it by how many times it should have shown up. So now when I add everything and I find my summation, right? When I find my summation of x minus x bar here, I'm going to be adding these numbers, not just that one. So it's this plus 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 that plus that plus that and plus that. Okay, so these multiplied versions account for how many times this number should have shown up if I had the space. Okay, so by doing that and adding all of these up together, I get a total of 69. So all of this adds up to 69.84. Okay, so my summation of x minus x bar is 69.84. Okay, well, the MAD formula takes this and divides by n, right? So I'm going to take this and I'm going to divide it by my n, which is 25. And that's going to give me an MAD value of 2.79. Okay, and many of you said that there's going to be a lot of variation, right? So there's my variation right there. I see that it's far from 0. It's almost a 3. So that tells me that there's good variation and variability in my data. Okay. Okay, I'm going to stop here for a second. Do we have any questions of any part? Any part you need re-explained, any part you need clarified, anything, just let me know. How can you determine?
So it's basically like what we did for the basketball thing, but like a shorter way. Okay.
For larger sets of data, yes. I'm trying to show you, like, this was a larger set of data, right? The basketball thing was like 8 data points. This had 25. So I'm just trying to show you, like, if you have repetition like this, how you can kind of shorten your work. Now, there's pros and cons to this. Yes, Dallas, there's pros and cons to this. The pro is less lines of work, right? The con is that a lot of kids forget to do this part at the end. So if you're going to do this, you have to be careful. You have to make sure you do the multiplication at the end. Otherwise, if you have this space on paper, write it all out. There's nothing wrong with it, right? Write it all out. It's going to repeat anyway, and you're going to see that it repeats. It's just a little bit extra writing. So if you know yourself and you're prone to forgetting as you're working through, because let's not lie to ourselves, this is a lot of work, right? It's very tedious work. It's easy, but it's tedious. Like it's very, like, it's easy to get lost in the numbers. So if you know that it's easy to get lost in the numbers for you, then I would just say list it all out. Don't even do the multiplication. Okay. I have a few of you guys asking me like, so how did we know that it was a good variability? How did we know that that number means it's good variation? Okay. The larger your MAD value, the more variation there is. So if my MAD value was closer to 0, if it was like, 0 point something, like 0.5 or 0.3, that means that it doesn't have a lot of variation. So the larger your MAD value, the more variation there is in your data. You also want to take a look at your MAD value in comparison to the range of your data. So notice our data ranged from 5 to 19, right? So that means that if we have a mean of 11.72, okay, we have the average distance is 2.72 from our mean. So that means that, or 2.79 from our mean, so almost 3 from the mean, right? So we're looking at like the 14s and we're looking at 15s and 16s, and we're looking at like 7s, 8s, and stuff like that. So it covers the variation in our data. It covers the variation in the data. Okay, so that means we have numbers above the mean and below the mean. Our numbers are not tightly around the mean. Okay, the more spread out your data is from your mean, the more variation that there is, the more variability that there is in your data. Does that make sense? So this tells me that there's a decent amount. If the average distance from the mean is a 2.79, it tells me that there's a decent amount of distance from the mean, right? And so that it has variability. It has variability. That's the important thing, right? Not having variability would mean that my average distance is very small, right? Like a 0 point something from our mean, and that means there isn't really much difference from the mean. Okay. Natalie Hun, yes, to get the 69.84, I just added all of these guys up. So I summed up all of my X minus X bars absolute valued. Okay. I hope that answered most of your guys' questions. And Dallas, yes, great questions there. Ishmael, great questions. Destiny, yes, it's just like the worksheet that we did. We're just kind of doing it ourselves. And with larger sets. So here's the thing. I'm not going to ask you to do anything larger than this because Lord knows it's a pain in the tuchus. And those of you that had FST with me last year, like Gabby, Ishmael, Katie, Maddie, this might be giving you guys like flashbacks to standard deviation.
PTSD.
PTSD, exactly. PTSD to standard deviation calculations. Believe me, guys, they did calculations like this for like 40, 45 data points. So this is nothing, but that doesn't mean that it's not also very, you have to just make sure you're paying attention to what you're doing. Okay. So what you're going to do, I know, anyone still need this? I was kind of talking so you guys could get some,
Miss K, I had a question real quick.
yes.
So I know you were showing us on doing the multiplication at the end. Can you, instead of doing the multiplication at the end, can you just add like however many duplicates there is? So like 8 parentheses, whatever number that is, minus the mean? Or would that mess it up?
8 parentheses.
And then if you do 4. No. How many
So,
8?
like this?
No, so you put the 8 out and then put the however many 8s there is in the parentheses. So 8 times 4 minus 11.72.
No, because then you would be doing 32 minus 11.72.
Okay.
No, it doesn't. No, it doesn't. You can't do the operations like that. What you could do is you could do the other way where you're doing, let me erase that. and choose a different color too, so we know what we're looking at. You could do 4 times 8 minus 11.72, like that. Because then this order of operation says you have to do the subtraction first
Mhm.
and then multiply, because it's 4 times whatever value you get here.
Okay.
Does that make sense?
Yeah.
Yeah. This 4 times, this 3 times is not necessarily a mathematical. It's more of like there's 4 of them.
Okay.
Yeah. So if you could think of it this way, but not the way that you said.
Okay. Thank you.
Good question. Good clarifying question. All right, ladies and gents, I'm going to clear these drawings. I hope everyone has them. Okay, I'm going to clear them in 3, 2, 1. Okay. So what we're going to work on is now you're going to do 2.4b. Okay, and 2.4b is essentially you calculating the MAD using that format. Okay, so you're going to be doing 2 sets of data. You're going to be working with 2 sets of data. Let me reshare my screen here so you guys can see what I'm seeing. Okay, and what you're working on is you have 2 sets of data here in your 2.4b. Okay, let's read the instructions. It says each of the dot plots below depicts the number of candies eaten by a group of 17 high school students on different days of the week. The means are given. Okay, so each dot plot has 17 students on there, 17 data. So that automatically tells you n is equal to 17. Not only that, you are told the means. You are given the means for these dot plots. Okay. Here's the mean for dot plot A. Here's the mean for dot plot C. Okay. So you are going to go ahead and you're going to answer these 2 questions and then calculate the MADs. Okay. You are then going to calculate the MADs. So looking at the questions here, based on these 2 dot plots, it says determine the shape of each distribution by highlighting the word corresponding with the option below. So A, right? So you tell me, is it left skewed, right skewed, or symmetric? So highlight one here. For C, left skewed, right skewed, or symmetric, highlight the one here, okay? Then, without doing any calculations, just by looking at the distributions, which graph, which dot plot do you think will have a larger MAD value? Remember, a larger MAD value means more variation, right? More variability. So which one do you think will have the larger MAD value? Just by looking at the dot plot, okay? Then you are expected to calculate the MAD. Okay, you are expected to calculate the mean absolute deviation using the tables. Okay, so each one is 17. Okay, so it's not as much, and you can use the duplicate trick that I just showed you. You're going to do this work on a separate sheet of paper and upload the picture. You could do it but on the table too, if you want to insert a table. So you can go to insert here and insert table, and then however many you want to do here. So you could do that here, or you can do it by hand on paper, take a picture of it, upload it to the document, then submit the document. Okay. So it is 11:36. It is 11:36. I'm going to give you guys 15 minutes. So you're going to work fast. Okay, you got to work fast. I'm going to give you guys 15 minutes to calculate, answer these questions, and then calculate the MAD for both of the graphs. Okay, you got to work fast, y'all. And then once you're done, we're going to come back to our PowerPoint. Okay, we're going to come back to the PowerPoint, and we have a journal entry to complete based on your findings. So I need you guys to work fast, okay? We have a summary statement, and then we'll finish off the class. Okay, so I'm going to give you guys 15 minutes now to work on the 2.4b. Yes, you have to calculate the MAD for both dot plots independently, right? So you're going to do dot plot A, find the MAD for that, and then dot plot B or dot plot C, find the MAD for that. Okay. So ready? Go.